Okay, so how many tangent lines to this curve from this point? At which point do these tangent lines occur? Okay, so this from advanced functions, roughly, you know, vertical asymptote is at -1. Horizontal is 1. When it's 0, it's 0. So it looks like this. When it's 0, it's 0. So I know it's going to look roughly like this, okay? 1, 2. So 1, this is 1. 2 is here. So it's clearly not on the, it's not on the curve. So it's outside the curve, right? So visually, it looks like we're going to get something that looks like this, and another one that looks like that. There's two answers. It looks like. Okay, so how do we do this? Okay. Any point on this, so let's assume where the tangent line meets the curve. Let's let that be A for x. So if it's A, because it's on the curve, right? If I call it AB, B will be A over A plus 1. Okay? So then the slope of this tangent, okay, slope of this line will be B minus 2 over A minus 1. Okay, which is, let's replace B with this. Okay, we want to do that because we want the expression of the slope to be as simple as possible. And when I say that, I mean like one variable, not two variables. Okay. So this is A minus 1. This is A minus 2 times this, so 2A minus 2. That gives you, it's negative, minus A minus 2. I'm just going to bring that to the bottom as a product. You get that, okay? Okay, so that's, you have to understand this is an expression of slope. So right now, it doesn't, this line doesn't, as it stands, it doesn't have to be a tangent. It could be just going through the curve like this, right? Because that point right there is also on the curve, so I could, you know, it could be represented by A and B, right? This slope here is a general expression of any slope with 1, 2, and 1 point on the curve. Doesn't matter where, but this is clearly not a tangent. I want this to be tangent, not just any, okay, slope, okay? But we know how to get the expression of slope using derivative. So let's do that. That's going to be x plus 1 minus x over x plus 1 squared using quotient rule. So if I replace x with A, then now this represents an expression of slopes that's only a tangent. So we can make these two equal to each other. If I make them equal to each other, now we're talking about A, so that's it's this line, but I only want the ones that are tangent, not just any random one that goes through the curve. Is that okay? Okay, that's our equation. So it still looks a little bit complicated, but I think it's simplified a lot if I multiply both sides by A plus 1. Okay, and then you can cross multiply, and then it's a quadratic. Okay, and this, whatever A we get, is going to be the A values on the curve, which will be a tangent. Going back to reviewing what happened here, this thing here is a slope between this point and anywhere on this curve. This can be slope only for tangents, right? And they're both functions of A. They're both some point on the curve, okay? If you make them equal to each other, then what you will get is only, so there's many tangent lines here. right? There could be tangent here, there could be tangent here, 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 here. All these are all tangents, right? But when you make them equal to each other and solve it, you'll only get the ones that are, not only are they tangents, but it'll go through this point as well. Okay, so that's the main idea. Okay, by making them equal to each other, you have to understand that's what it's doing. Okay, so now let's solve this. I'm just going to multiply both sides by negative and just expand this and turn this into 1 minus a. Right, that's what happens if I multiply both sides by negative 1. And I get a squared plus 3a plus 2, 4a plus 1. So this is not factorable, so we've got to use a quadratic formula. A will equal to minus 4 plus minus 4 squared. You can factor out a 4 as a 2 outside the root. So it's minus 2 when you reduce, plus minus root 3. Okay. So those are the two locations. Minus 2 plus root 3, x equals minus 2 plus root 3, and y equals minus 2 minus root 3. And the y coordinate, get the y coordinate by plugging back into the parabola. If you add a 1 to this, you get negative 1 plus root 3. Okay, minus 2 minus root 3, add a 1, like that. So it'll be xy coordinate, right? I meant this to be x, right? xy coordinates. This is 1, 2 points where we get the tangent.